Hello everyone, welcome back to my YouTube channel. In this video, we'll solve a simple problem on node analysis. That is nothing but find a node voltage for a given circuit. This is a circuit. So the first thing is should give the direction of current to this node. Only one major node is there and we'll be having one reference node. And 50 at an angle of 0 degree voltage supply it is having on left hand side, 50 at an angle of 0 degree voltage supply on right hand side, 3 ohm, 3 ohm and J5 ohm. They are asking find a node voltage for given circuit. There is only one node voltage. I am marking that as a V1. And the nodal analysis, either you can assume the direction of current from major node, either it is away from the major node or else towards the major node. So here I am assuming there are three branches at 3 ohm, at 3 ohm and J5 ohm, at 3 ohm and J8 ohm. I am assuming that there are three branch currents which are leaving from major node, that is V1. I am naming that as I1, I2, I3. So now we should write the current equation. I is given by V divided by R. So current flows from major node. Tail end is V1, arrow end is reference and is 50 ohm, 50 at an angle of 0 degree volts. So the current for nodal analysis, you are writing that tail end voltage minus arrow end voltage divided by resistor. So that I1 you are writing it as V1 minus 50 at an angle of 0 degrees, nothing but 50 only, minus V reference. V reference is 0. That is why I1 is given by V1 minus 50 at an angle of 0 degree divided by 3 ohm. Similarly, V2 your I2 you are writing that as V1 minus 0 divided by 3 plus J5, and I3 you are writing it as a V1 minus 50 at an angle of 0 degree divided by 3 minus J8. So now we apply KVL at V1, that is all the currents are leaving, minus I1 minus I2 minus I3 equals 0. That is nothing but I1 plus I2 plus I3 equals 0. The sum of current leaving from the junction equals to sum of the current entering the junction. Leaving the currents are 3, there is no entering, that is why I1 plus I2 plus I3 equals 0. The next, so you are applying the KVL, you are getting these three currents, I1 plus I2 plus I3. So now I am writing this I1 as, with the help of calculator, just see here. For this calculator, you can go to the CMPLX form, and this V1 minus 50 divided by 3, I am rewriting that as 1 divided by 3 into V1 minus 50 divided by 3. So that 1 divided by 3 is nothing but, go to complex mode, select second one. V1 divided by 3 is nothing but 1 divided by 3 into V1. 1 by 3 is 0.33. So that I am writing here 0.33 V1 minus 50 divided by 3. That's nothing but 16.667. Similarly, for the second current, that is V1 divided by 3 plus J5, that is nothing but 1 divided by 3 plus 5I. Should write 3 plus 5I, I will get 0.088. It is a real term, so you can see R and I. Real value is 0.088 and the imaginary value is minus 0.147. Therefore, we are getting this. Similarly, the next is V1 minus 50. 1 divided by 3 minus 8I. You will be getting 0.04, and 50 divided by 3 minus J8, you are getting real terms and imaginary term, both you have tried. That is nothing but 2.05. We'll be having minus 50 minus 2.05 minus into minus plus 5.5, and you are adding all this. I am separating that V1 terminal, that is 0.33 V1 plus 0.088 V1 minus 0.147 I V1 The same thing I am entering to the calculator, and plus 0.04 V1 plus 0.109 V1 the I into V1. So I'm taking V1 as a common. So I'll get a final answer as 0.458. Shift and equal, you'll get imaginary term, that is minus 0.038 into V1. And the constant terminal is only minus 2.5 plus 5.479 I. I'm sending this to right side. It becomes 2.05 minus 5.479 I. Then V1 I want, I am sending this terminal to right side. It becomes divided by, therefore you're getting V1 as 5.431 minus 11.512 volts. To convert this into polar, again you can use shift and minus. Sorry, shift and plus. Then you press equal, will get magnitude value. Shift and equal, will get angle. So this is about numerical. If you are having any doubts in a numerical, feel free to write in the comment box. If you like this video, do subscribe and share maximum. Thank you so much. Have a nice day.